Good morning, everybody. Give just a few minutes here for everybody to join in here, and we'll get started with the webinar. All right. Good morning, everyone. I'm Executive Director Brett Stanton of the Asphalt Pavement Association of Michigan, and I want to welcome you to our webinar series. This is part 3 of the webinar series. It's part 2 on the asphalt plant side of things. It's titled Show Me the Money, targeting areas at your asphalt plant where you can save money. So I want to thank our sponsors for today's webinar, who include Aztec, CWMF, and Meeker. Also like to thank the audience. Your participation is greatly appreciated. Before we get started, I want to go through some just typical Zoom controls here. We have obviously the webinar set up, so depending on the version of Zoom you have, there'll be a Q&A box either at the bottom of your screen. Sometimes you have to mouse over in order to get it to show up. Otherwise, it could be at the top of your screen. So just mouse around and you'll find it. There's also a raise your hand function. We will be doing something a little bit different today. Our speaker is going to be trying something to keep the audience a little more engaged, using some whiteboard and some slides and stuff like that. We'll also be utilizing a couple polls, so just be on the lookout for that so you can participate in those things. We'll do a full Q&A at the end of the session, but feel free to type questions in as we go along, as you think of them, and we'll ask Lance, our presenter, at the end of the presentation. So we're scheduled for an hour and a half. We might not use that entire hour and a half, but there will be professional development hours. So if you don't have a boatload of those already and you're needing more, we will promptly after this use the sign-in log from Zoom to put together PDH certificates. And we'll plan on doing an hour. If we end up going the hour and a half, we'll make sure that the professional development hours reflect how long we spent doing the webinar here. So in order to get the PDHs for the event, we're making sure that you've been here for 85% of the total event. So, and of course, if you have any questions or need it in a different format for whatever licensing agency that you have, feel free to reach out to us. We'd be more than happy to help. So like I said, today's webinar is part 3 in the webinar series. Show Me the Money. So the webinar goals today are to learn about locations around your plant where you can have the opportunity to save money via decreased downtime, increase efficiency, improve performance. And like I said, really the end goal is to save dinero. So I'll introduce today's presenter. Today's presenter is Lance Clark from Aztec Industries. Lance is Aztec's product manager of domestic asphalt plants and industrial equipment. Here he's responsible for maintaining Aztec's product portfolio of domestic hot mix asphalt equipment and interpreting market activity. Lance has been in the road construction industry for 14 years. During that time, he has worked in various roles, including equipment design, project engineering, regional sales manager, and now product manager. Lance has managed crushing and screening equipment installs, upgrading of asphalt plant equipment, as well as rail developments for aggregate sales yards. Before Aztec, he managed sales tech territory for Heat Tech Inc., which focused heavily on liquid asphalt storage. Lance lives in Northwest Georgia with his wife and 2 kids. In his spare time, he loves to travel and spend time with his family, eat good food, and enjoy the outdoors. So I want to thank Lance for taking time out of his busy schedule to present. With that, Lance, I will turn it over to you, give you give you the opportunity here. And so, like I said, he's trying a couple new things here, trying to present in front of a whiteboard as well as show some slides. So bear with us here on the polls and things like that. But I think Lance has been practicing and things will go well. So with Lance, I will stop sharing my screen here and give you control.
There we go. Can you hear me?
Yes, sir.
All right, very good. Well, good morning, everybody. Thanks to Brett for that kind introduction. It always feels kind of weird hearing somebody talk about you, but I appreciate Asphalt Pavement Association of Michigan allowing us to come on and talk this morning. As he said, my name is Lance Clark, and I'm a product manager here for Aztec Industries, specifically focusing on domestic asphalt plants and some industrial equipment. But the majority of my time and tenure, I don't want to spend too long talking about myself, but just so that way you know who I am and who's presenting to you, is that I spent the majority of my life in engineering, either with Aztec or with I worked for another company and that just sold and crushed rock, and we just crushed it and sold it. But have had plenty of opportunities through the Aztec Industries family of companies to move into different roles, and most recently was with Heat Tech, selling asphalt, liquid handling, storage equipment, and have transitioned in the restructure with our company, as hopefully some of you have already seen through our website, transitioning into One Aztec. We have transitioned, and now I'm a product manager, which is a fairly new role for us, but trying to focus primarily on domestic asphalt plants and where we're at in the market. So enough of that introduction. Today, I want this to be a little unconventional, because in our current climate, in-person meetings are, I don't want to say a thing of the past, but currently are a little hectic. So we're doing a lot of stuff virtual, and I don't know about you guys. I don't know from who all's on here, but I get tired of hearing somebody present just through some PowerPoints. Just put up a PowerPoint and go through it. And so I want to be a little unconventional this morning. I hope you guys will bear with me and accept that. And what I'm going to do is, I've got a whiteboard behind me. We'll do some writing, and then I've got my laptop right here. So if you see me, looking right here, I've got my laptop, and I'm going to scroll it between some slides, so that way I can show you some stuff. But the PowerPoint is a great tool. I hope I didn't offend anybody saying that. It's just that I wanted this to be very visual and kinesthetic almost. That way, most everybody that I'm probably talking to learns by getting your hands on it, right, and seeing it visually. So I hope this comes across well, and I hope you guys get a lot out of it. So the name that Brett and I picked out for this is "Show Me the Money," right? Everybody wants to make it rain, right? And I thought of that song, which you guys probably have no idea what I'm talking about, but it's all about the money. I feel like when I'm talking with asphalt contractors, as long as you're talking about simplicity and saving money, you're doing good. Because that's what we care most about, right? Other than, we want our guys to be safe, we want them to go home to their families, but we want it to be simple and easy to work with, and we want to make a profit in what we do, because we can't keep the doors open if we don't have a profit. So that's kind of what I want to focus on with this talk. And with that being said, I want to go ahead and start out. I'm going to share my screen with you. Get to it. And I hope that you guys can see that. This is a estimate that I got from one of our very kind customers, and it doesn't show any pricing on here, but it shows the factors that go into a total cost of mix. So like in a ton of asphalt, what makes up the cost of that ton of asphalt? And as you can see, The material prices are the lion's share of that. And if I could, I would like to poll the audience. That's what Brett referred to earlier, is that I'd like to poll the audience and see, do you guys have a similar breakdown that is similar to this? This specific one that you're looking at was from a customer that has 4 asphalt plants. One's a batch plant, the other 3 are continuous. They all run on natural gas, so that's why the fuel's a little bit different. You know, they're not burning diesel. But I was hoping you guys would kind of look at this and say, yeah, he's on track. It doesn't have to be perfect, but I just wanted to see if you guys looked at it about the same. I'll give everybody kind of a minute to get there. Hopefully everybody's had time to do that. So, all right, that's awesome. I got that back. So a whole bunch said yes, that it's similar. So I appreciate it. I'm glad that it's at least tracking. I'm sure there's some differences, but I appreciate your honesty. What I want to focus on is that the idea is to sell at market value, sell your product at market value, and provide excellent customer service with a great product. So what factors do we look at for the mixed cost, and how can we drive them down, right? So this morning, I'm going to focus on a couple of areas in this pie chart that is going to be around the fuel and your electric costs. Now, I understand that the lion's share is the material prices, but unfortunately you have to do that through your suppliers, right? That's not something that a equipment provider, thank you, can help with, but we can help as far as on the equipment side for the fuel usage and the electrical usage. We can definitely help you there. So I'm going to stop sharing and hope everybody is out of presentation mode now. So I just want to boil it down to 3 very easy things this morning. And again, I asked myself when I was putting this presentation together, if I could essentially do 3 things to every asphalt plant to help them run more efficiently, what would they be? If I only had just a handful of time and a handful of these people to talk to, what would I want to drive home? And it's just 3 really easy things. And the majority of you are probably already doing this. But regardless, I have been at many asphalt plants from coast to coast, north to south, all across our great nation. And there are still contractors not doing these 3 very simple things that will save you lots of money in an asphalt plant. So drum roll, please, right? I'm trying to build it up, fireworks and boom, boom, show me the money, right? So the first thing is, I'll just go through these 3 real quick, is that to slope and grade your stockpile. The second thing is to use a VFD on the bag house fan. And the third thing is insulate your piping in the tank farm. It's like, well, holy cow, right? That's not that great, Lance, sorry. But it amazes me, anytime, any place we visit or go to, they're not doing these things. They're not doing 3 very, very simple things to do that. And it's always time, right? Time and money. Is we don't have the time or we don't have the money. But hopefully through this, I can shed a little bit of light to what's going on. So the first thing that we're going to cover, and I'm going to get my handy dandy marker here, is we're going to talk about the stockpile area, right? Because if you guys don't take anything away from this, absolutely anything from this presentation, I want you to take this statement, is that material moisture is the primary factor that creates variability in the maximum production rate of an asphalt plant. Gillette, it's, yeah. Sorry, I got a coworker come in here and he's already flipping lights and pushing buttons. So I'll say that again because it's extremely important, is that material moisture is the primary factor that creates variability in maximum production rate of the asphalt plant. So I hope everybody gets that, is that the main purpose of an asphalt plant is to do what? Is to heat up aggregate, right, and mix it with liquid asphalt. That is its primary role. Well, the higher the moisture content of the aggregate going into the drum affects the maximum output of the asphalt plant, because you're not just heating the rock, you're heating what? Hopefully everybody collectively said steam or what? Moisture, water. It creates steam, right? And what that does, it robs production from the baghouse. So the more moisture that you have in your aggregates, the harder it is to run bigger, faster, heavier, longer, is if you're dealing with wet aggregates. So how can we help that? How can we do that with the least amount of effort, right? Because somebody's still burning diesel, somebody's still burning natural gas, somebody's still burning waste oil. In those things, that's how we drive moisture out in the process, right? So what we can do is try to think about it and engineer it out, engineer the moisture out of the product. So I'm going to turn my back just a second and come over here. Hopefully everybody can still see. And what I'm going to do is I'm going to draw a set of coal feed bins. Hopefully everybody understands what I'm drawing here. Is a set of coal feed bins. And the loader has got to feed this, right? Because this is at grade level. And the loader has got to feed this baby. He's got to feed that. That's a terrible loader, I know. So don't make too much fun of me, right? It's got an exhaust stack and got windows, all that good stuff. Put a door. So what's going on over here? He's loading this, but he also has a stockpile, right? And as moisture comes down and soaks these piles, if there is nothing to keep the water from draining off, then it will just pool up under the pile. So ideally what we would want is, as the loader is feeding this, already starting off wrong, as the loader is feeding this, that we have a slope to maintain. And the loader is still here feeding the bins, and the aggregate pile comes down like this and allows the moisture to run off and collect down here. And the loader, of course, you want it to try to grab a bucket here in this area, but you also want this to be about the same distance. And typically this is somewhere around 4 to 6 feet, just throwing a number out there so that way you got it. Is 4 to 6 feet. I hope everybody can see what I'm writing here. And what that allows is the moisture to get out of the product, is get out of the material before it ever goes into the drum. So I'm going to go back and I'm going to share my screen with you again. And I'm going to show you what that looks like. All right, everybody remember this slide? So we're trying to help fuel and electricity, right? Well, look at these stockpiles. Hopefully everybody can see what I'm showing you here. Look at these stockpiles. Here's the asphalt plant over here. And here are the coal feed bins, and here's the products that they're pulling from. Look at this. Look at the back and where it's going. Now, again, I realize that not everybody has, trust me, I know the arguments, right? Is that we don't have the split space, we don't have the place for it, we don't have the drainage ability, we don't have There's a ton of we don't have, right, that we can list out. But my job is to just tell you best practices. So this can't necessarily apply to every single asphalt plant. However, if you have the ability and the room and the real estate to do it, this is the easiest way to get moisture out of a product without burning a fuel. Now, here's another really good thing that this is also really good is that the different products act differently, right? I'm sure all you QC guys out there nod your head. Some of the products act completely different. So if you have a sand or a screening pile, it is going to retain a lot more moisture than your 57 stone or your 5s or whatever range that you guys have it in, from the 1.5 inch, from 1 inch to 1 inch, or from 1 inch to 1/2 inch stone. It is going to grade I'm sorry, I didn't mean to say grade. It is going to, wick the moisture away better because it's already porous, right? It doesn't have as much surface area, so it's going to drain out. So, and they drain quick. That's the good part, is that they drain pretty quick. So the moisture the materials that hold the most moisture, like sand and screenings, that is where you can section off a part on the yard and pave and slope in that application. So that way, if you just have one small area and you only have a certain amount of time or budget to do this in, just do the aggregates and the materials where it makes sense. Even your wrap, even your recycle. I know that probably some of you guys are sitting on a mountain of it, some are not. I don't know everybody's situation. Some guys are hand them out. As much as they mill, they try to use. Some guys are sitting on a mountain, some guys can't buy it. So I don't know where a lot of you guys are specifically at in the market, but even doing it with wrap. Let's say you have a process pile that you've got your tear-offs and you've got your milling pile, and then you have a processing pile. Maybe you have a third-party contractor that comes in and screens it and classifies it and crushes it for you. And you take that product and put it on a specific stockpile area on the yard, slope and grade that, because think of the amount of moisture that you have that are in those products as well. They hold moisture just about as bad as sand does. So on average, just so that way you kind of know what I'm talking about, and there is a little bit of data to back it up, is that kind of a normal savings that you get sloping and grading is somewhere around 2% moisture. So if it is at 8% moisture content and you slope and grade the site, then you're at 6%. Now, other products act completely different. I have to, reference some of this material here because I'm, standing on the shoulders of greatness, right? Especially just people that have come before me in the past. But, I've gotten a lot of information for this PowerPoint presentation, or for this presentation today, from a lot of our technical papers. So, I have to give credit to, that way I don't plagiarize it, right? You get in trouble for that in school. So I have to say that I got a lot of my information through our technical papers. But, in these, there are specific tests where they got up to 5% difference, in one product that was on a job site, same product that was sloped, and another product that was not sloped. So essentially two different product piles, one sloped, the other same product, and there was a 5% variance in that. So, it acts differently when I said that 2% from just an array of products. That's just a rule of thumb, essentially like a finger in the wind to just check and make sure that it's going well. So paving and grading your stockpiles, great thing, great asset to the plant. So that way you're driving down your cost. You're driving down your fuel costs, and you're driving down your energy costs. And the good part is that if you have the ability to set it up from a greenfield side and do it properly, you can even set it up where it's on the same grade. So like in this photograph here, or in this picture here, if you were to have sloped that like this, the loader is still on the same elevation as the bins. And now you don't have that uphill pull on the transmission of the tractor. So that way, now you're saving wear and tear on the loader as well, because you got to remember in that mixed cost estimate, you know, equipment is in there. So if you can even do it to save on wear and tear of your loader, I mean, think of the money that you would could save, or the maintenance that you could push off if you didn't have the extra wear and tear on the loader too. So that's my thought. I could mic drop right here and be done, but I've got two more things I want to talk to you about. But I hope if you get nothing else from this today, that's what you take, because that's something that you guys already have, right? Everybody has a motor grader, everybody has a paver, and most of the time you can get a truck. It's just having the money and the effort to do it. Now, everybody's a little bit different, you know, in their costs and their fuel savings. So I'm not going to go into like, you're going to save $1 million a year doing this, because everybody's scenario is different. So I'm just not going to go into that, because I know I'll get hung up and they'll say that Aztec guy told me it was going to save me $1 million and it didn't do it. So I'm not going to go down that path. So I'm going to keep moving on. And the next thing that I want to talk about is a VFD for the exhaust fan. So that's something that is pretty commonplace, right? Is again, I know probably when I said these three things at the beginning of the presentation that you guys were like, oh my gosh, you know, these are three things I'm already doing. Well, you would be surprised. I literally visited a plant. I guess it was 2 weeks ago now. It wasn't last week, the week before. He had just literally that month put a VFD on his exhaust fan. Now, to me, that's pretty common because we do it a lot on our equipment. However, there are customers out there that, and even some of our service guys that don't want a VFD on their exhaust fan, right? And why is that? Why do they not want one? And it's because it's something else to fail, right? And get the lead time on a VFD is a lot worse than just getting a starter for the plant. And having a mechanical damper is easier to maintain and work on as opposed to something that's electronic that's driving the fan up and down. But again, we can, just like with anything else with asphalt, we can get into it and have a bazillion different opinions. But again, my job here is to just give you best practices and recommendations on how to save money. And my recommendation is add a VFD to the exhaust fan. Now, the reason I say that is because at an asphalt plant, electric motors use about 80% of the electricity consumed. So fans, pumps, and compressors, you know, things like that run just constantly are tremendous draws for the electrical consumption. So out of that 80%, half of that 80% is the actual, sorry, I think I said that wrong. 80% is from electric motors all throughout the plant. But out of that half, so half of that 80 is the fans and the pumps and the compressor. So I said that wrong. I'm sorry and I hope you guys are okay. Like, you know, I don't present every week, and I'm not overly, clearly, right? I'm not overly tailored, I guess, if that's the right way to say it. So I hope you guys are bearing with me and are okay with my Southern drawl and just overall trying to be laid back about it. I hope you guys are all right with that. So if I misspeak, I promise it's not I'm not doing it on purpose. So let me just throw that caveat out there. So, and I'm a little nervous too, that I shouldn't admit that, right? So let's go back to what I was talking about, is the fans and the pumps and the compressors taking up about 40, half of that 80% demand. So in these applications, if energy can be reduced by utilizing a VFD instead of a mechanical damper, what we find is that there is a relationship with the horsepower percentage and airflow percentage. And since not all plants are operating at 100% maximum output, the fan does not need to run at 100%. So if the airflow can be varied by the RPMs of the motor, which will decrease the airflow, that's what we should do, right? If you're running along and you have a plant that is sized with baghouse, the burner, and the drum combination, and everything else, your belts and your drag, your slack conveyor, or your bucket elevator, whatever you have to convey the material, if everything is set up to run 400 tons an hour on a daily basis, how often are you really doing that? And again, I realize who I'm talking to. I'm talking to a bunch of guys that love production, right? They just want to push the gas and go. But in all reality, how often are you hitting 400 ton an hour? I can tell you the majority of them that I've been in ain't doing it. I'm not going to say that they don't, never have, never will. I'm just saying on an average of their run cycle, the average is a lot of times half the percentage. So if they have a 400 ton an hour plant, their average is 180 or 200. If they have a 300 ton an hour plant, they average 150. Or 180, something like that. The majority of our plants are not running at 100%. So why would we run the fan at 100% maximum output all the time when we have the ability to vary that speed? And again, I realize as I'm saying that, it creates complexity and extra hardware, but regardless, it saves you money and it's a good fit because it saves you wear and tear on the fan. So I'm going to turn around here again. And I'm going to erase, actually, I'm just going to do it right here. That's okay. I might step out of the camera a little bit. But what this will show, and again, I'm probably going to do a terrible job at this, but I'm going to try. So we're just going to do like a regular XY axis. So this is going to represent pressure through the system, and this is going to represent airflow. And on a common asphalt plant, and again, I know, not everybody's got one different. Mine's set up this way. This is over here. I've got elevators and you've got drags. But through a typical system, going through going through the entire system of the ductwork or through the drum and trying to understand that airflow, that curve, that fan curve, if you will, looks something similar to this. So as the airflow increases, the pressure increases. I'm going to change colors on you here. And the motor, the actual fan RPM, looks something similar to this. When it starts, and this is on a mechanical damper now, right? I'm sorry, I'm probably talking two different speeds. This is going to be based off of a mechanical damper. So with a mechanical damper, you hit go and boom, it is turning. So it's automatically at my top, and as it changes, it does this number and kind of falls off. Sorry, I know I didn't mean to do that. Sorry, I was standing right in the way. So if we add in horsepower, it looks something, I'm going to change colors again, like this. So what does that mean, right? You're like, dude, I don't have no clue what you're even talking about. Is that what we have to do is the baghouse fan damper is way down the line, right? It's sitting right on top of the fan. So if you have an issue at the front of the system, like you're puffing, you've got too much airflow, it's the drum is puffing right above a puff, right? And it's puffing too much and you have to increase it or decrease it, whichever direction you're going, up or down. As you change that airflow, it tends to get off skew if you're increasing or decreasing. So as your fan curve will change because you're adding more pressure into the system, because you're essentially choking the fan off, and you're adding more pressure into the baghouse as you're doing that. But what happens when you add a VFD to the system, this neat little curve right here that we had for our fan, now all we have to vary is the fan RPMs. So instead of here, we can vary it down to decrease production, or we can vary it up to increase production. And guess what? There's no damper for opposition in the system. There is no extra added static pressure. And if you look at the horsepower when it comes across, like if I were to have lines here, probably can't see that. If you look at this, look at the horsepower requirements, where they are in association to these curves. So as the airflow increases, up here, and your RPMs change on your motor, you're speeding it up and down, your horsepower changes. So what that allows for is at 50% airflow, you're only at about 12% of the power required. And at 75% of the airflow, like when you get over here, only 42% of the power is required. So think of the savings that you're going to get by adding a VFD in this system, just by controlling the power or the power demand at the asphalt plant through the fan. Is just by varying the speed, you're consuming less energy. Now, there's also what I said earlier that's great about this too, is that you also save on the wear and tear of the fan. Is that you're not turning it at it's wide open all the time, also increasing and decreasing the static pressure inside the fan. So you're really giving the fan a break by adding that VFD on there. So there's also a second way that we can look at this too. And this gets into some stuff that not that I understand this overly great, but some on the utility side here is that there are periods that your utility company will look at, and I've heard as low as 15-minute intervals, and I've heard as much as 30-minute intervals that utility companies will look at, and they will measure that interval in whatever peak demand you had at that time. So in the plant start up running, when you're boom, 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 starting all the motors, and the electrical demand is going up and up and up. If they look at that 15-minute interval, they are going to charge you the highest rate because of the demand at the plant. But adding a VFD to the largest motor at the plant, typically, I know some motors on the drums can be very big, but typically the baghouse motor is a big draw. Adding a VFD will allow the load to be ramped up very slowly, and not slowly like a snail's pace, but slowly as over the course of a few seconds, as opposed to just an instantaneous inrush of all the current to the motor. It ramps the motor current up slowly, so that way it doesn't have that peak. It just has a slow startup curve to where it needs to be. So adding a VFD not only helps with wear and tear on the fan, it helps production and helps save on electric costs just every day running, but it also helps demand charges from your utility company. And there's a lot of times that these companies, we've just seen it through the US. Can't speak on Michigan specifically, but I know through the US that some companies have incentive programs. Like if you will install these, they give you a certain, an incentive program to give you a certain amount off your power bill for that. So that helps in the ROI in returning that. So, so if I can leave you with anything with that, if that's something that you're interested in and that you're thinking about, and you have a vendor of choice that you like to use, the only thing that just to keep you guys from getting snake bit is that make sure that the motor is inverter rated. Make sure that your motor has that duty, is going to be sized for that duty cycle, and that where you locate the VFD is extremely important. You typically want the VFD drive fairly close to the motor, so that way the cable from the drive to the motor is not really far. And also, VFDs don't like weather. If you can imagine that, they're a little finicky. So if you can put them in a climate controlled area, they will last longer, have less hiccups, have less issues. If you, there's even cabinets that you can buy that are outdoor rated, that are air conditioned, that bring air in from the bottom and circulate it through the top. And it's NEMA, I think it's even 3R or even up to 4 or 5. I don't remember the rating. I know 3R it meets that criteria, but it's enclosed, it's sealed. It has its own air conditioner in it, and they work great. We've used a lot of those through the years, and that's a great way. If it has to live outside, then that's a great application to do that. If you don't have room in your motor control center or in your power room, you might just have a bank of electrical boxes mounted on a wall with breakers and starters in it. And if you can't add a drive in there, this is an option to go outside. So, and I guess the only other thing that I would say before I change gears again is make sure that the lines, when you're running these lines, it's not close to low voltage, because when you run those large lines, especially on a baghouse fan that has really large cables, that it's not near low voltage lines, because that can mess up. You can get noise in the lines, and it'll mess up those signal cables. So it's just a couple of things to keep your thought on, keep your thoughts if you're interested in something like that. So the last thing, this is my last and final thing, right? As I wanted to talk about 3 different things, is the tank farm. That always is the area that nobody wants to go in, right? Because there's water in there. You had a truck driver have a spill. You had a pipe come loose. You had a valve that wouldn't close, and you overfilled the tank, or any of the above. And again, I know nobody on this call has ever had that happen, right? Not a single person has ever had that happen, right? And you guys are perfect, and I'm the only one that has to deal with that kind of stuff. I understand. But in the years that I spent on the road, calling on customers and specifically just talking about liquid asphalt storage and heating and transferring materials and keeping it good and hot, it amazed me at the amount of contractors that would not insulate their piping, that and honestly would knock down, drag out, argue with you about it. And I just learned, just like now, I've said it multiple times, us as an asphalt community, asphalt contractors community, we don't shy away from our opinions, do we? We like to give our opinions. We like to tell each other what we think's better, and you're dumb for running that. I'm not advocating that. I'm just being real. Is that we like to pick at each other and say that one way is better than the other. Well, I primarily focused on customers that was kind of in like the south central part of the U.S. So like Texas, Oklahoma, Arkansas, Louisiana. A lot of those companies are states that were in hot zones. It's always hot in Texas. It's always hot in Louisiana, and even now, my heart goes out to with everything that's went on and with Ida. We're having some. I'm here at Aztec Industries today, and that's in Chattanooga, Tennessee, we're right on that band, and we've got some terrible weather out here today. I don't know about you guys, what you are experiencing, but we're seeing the effects of that today, and it's just heavy rain. And my heart goes out to the folks that have struggled in New Orleans with Ida, and a lot of them were contractors that I called on and have a great relationship with, and I feel for those guys, because I have no clue what they're going through right now. I'm sure their panel boxes and trucks are underwater. So definitely feel for those guys. But the point that I'm trying to make with that, I'm sorry I got off topic, but those guys, when they live in those states like that, they just automatically think, well, it's hot outside. Why would I need insulation? You know, it's 90 degrees out here and 100% humidity. I'm sweating as I'm talking to you. Why would I need to insulate the piping? And our previous service manager at Heat Tech, his name was Ron Henry. Some of you guys might know Ron. Ron used to always say, when the ambient temperature outside is 300 degrees, come talk to me. So I always like that saying, because, you know, hot is a relative term, right? Think of the difference between 70 degrees and 90 degrees. That's just two, and just the same humidity. Say it was the same humidity, 70 degrees and 90 degrees. It's hotter, right? Well, that's 20 degrees difference. Well, think of 200 degrees difference from that. To go up to, you know, 300 degrees, because all your heaters, all you guys are running heaters set at 300 or maybe even 320 or 330 or something like that. But that is a tremendous amount of heat that is being produced to maintain the temperature of the liquid asphalt at the facilities. And just insulating the piping goes such a long way. I am telling you, it makes so much difference. You with an uninsulated piping, and I'm just going to use a hot oil pipe, for example. Typically it's 1.5 inches. You see a lot of asphalt plants that have 1.5 inches or 1 inch or 3/4 lines that are transferring the thermal fluid from the heater to the tanks or the pumps or anything, and all that heating equipment, and they're not insulated. And just adding an 1.5 inch layer of insulation on those lines just go hundreds of miles in to help the efficiency of the plant. So just the pipe itself, uninsulated, 1.5 inch hot oil lines, you lose about 482 BTUs an hour on uninsulated piping. But if you wrap it, like I was saying a second ago, with 1.5 inches, that can save you, or you can bring that factor down from 482 to 54 BTUs per hour on just a foot of piping. Just 1 foot linear piping, 1.5 inches, you go from 482 BTUs an hour to 54 BTUs an hour, that is just insane at the difference. So if you add that up over the course of, you know, an asphalt plant, it might have 100. I mean, I've seen them as far as 200 feet of linear piping, because what are we all doing now? We're running more tanks because we got more mixed designs in different gradations of asphalt. So you've got, a 64 minus 22 tank, a 70 minus 22 tank, a 76 minus 22 tank. You might even have a 58-28 tank. You might have an 86-22, for some nuts job that you guys are going to run. I've seen it all over the place. So with adding all of those tanks and adding all of that, it takes down the efficiency of the heater, because the heater is what's pumping out the work, right? The heater is what is actually doing that. So it's very important that we maintain the heater's efficiency. And how do we do that? And one of the questions that I wanted to poll you guys again, so I hope you guys are still with me. I hope you guys are still here and you're awake, and you probably think I'm nuts. But if you guys are still with me, I'm going to ask you a question, and I'd like to do another poll, Brett, if we can do this, is that do you have someone that comes to your facility and tunes your burner for you annually? Let's just say annually. Ideally, you do it, twice a year, spring startup and sometime in the winter, or during run season. Just to make sure everything's working right. Do you guys do that? I'll give you a second to answer that question. All right, you guys are awesome. Everybody said yes. Good for you. I am proud of you. If I could give you, I hope you can take that. That's a high five because you guys are awesome. So most people don't do that. They don't tune their heaters up, and they can get out of whack because we want one that's modulating, right? We want one that's, if it requires more heat, it ramps it up. And if it requires less heat, we ramp it down. Almost like a VFD, right? Modulating motor, to that way you're not running full bore or any lower. You want something that will modulate, so that way you're saving fuel and you're saving energy. Well, as they do that through the years or through the year, it kind of will work that mechanical linkage loose. So it's always important to have somebody come in and just test it and make sure that everything's looking good. You're not burning unused fuel. You have the right amount of air going through the system, and everything is happy. Everything looks good, because we don't want to shut down, right? We don't want to be, oh, the heater just crapped out, now we got to call the trucks off. So that's a bad day, right? So if there's anything else that I can say as far as the tank farm is concerned, is that the heater will run most efficiently as long as you're maintaining your heat load. And what I mean by that is that your terminal or the refinery or the wholesale, wherever you're getting your liquid, wherever that is coming from, it is easier to take it off of the truck at 300 plus degrees, because they're going to heat it up to transfer it, right? They've got to heat it up to pump it into the tanker, and they have to maintain that temperature, so that way when they offload into the tanks, it pumps out and it gets all the way out, right? You don't want to be carrying a tanker back that's got some residual in it. You want it all to come out. So it's easier to put hot liquid in the AC tanks and maintain that temperature, as opposed to letting that temperature fall and then boost the temperature up to where you need it to be for production. Because what do we do at the asphalt plant, right? We turn the mix up. We think, we get that gypsy guy in there that says, man, I want an extra hot load, right? I want it extra hot. Well, it's easier to keep your material at temperature just as you put it in. The heater will run more efficiently doing that. And what I mean by more efficiently is that it is going to burn less fuel. Maintaining that temperature, as long as the tanks have good insulation, have plenty of insulation, the right amount, and that everything is, you don't have any jumpers restricting flow in the system, and it's got, good flow, you're going to be fine. The heater is at its most efficient point, and especially if you tune it every year like you guys have. So it's critical that we do that, is try to maintain, just have what I call a maintenance load. Have the tank farm on a maintenance load. So that way you're not boosting your asphalt temperature all the time, and you're just wasting fuel doing that, with the burner just running wide open and turning off. Because you got to remember, this scenario is similar to like the tortoise and the hare, where the big burner on the drum, you run that only as necessary. And yeah, it uses more fuel, but you also turn it off at the end of the day. You run your shift, you turn it off. What's out there purring all night long, day after day? The heater or the burner on the heater. So if it is tuned right and it has good flow, then you won't have any problems. And it's running as efficient as it can. And this is just a tidbit, is that one other thing that I've seen, especially within past couple of years, is the thermal fluid, the different brands of thermal fluid out there, and check it every once in a while. You know, don't just run. Check the thermal fluid every once in a while, and don't check it from the expansion tank, because the expansion tank is there to move as it expands and contracts. So if you dip the expansion tank, your test is going to come back crazy, because it has particulate in it, and it has it might even have some sludge in it, because it's been sitting there a long time. So if you've got a good place that you can break a line and get us an oil test, I highly recommend that. And if you need recommendations on people I'm sure you have local suppliers, and I'm sure they do a great job, and get with them. But if you need some help with that, get with your vendor of choice, and I know that they'll all help you as needed. So in conclusion, I'm gonna wrap up here just a second. I'm gonna share my screen with you one more time, so that way you can see this last PowerPoint slide. Just a second. So in conclusion, there are many ways to save money in an asphalt plant. Some of them are easy, some of them are very complex. But if you look at this list that I've got shown here, there's 9 different factors that go into a plant's production. And if you look over this list of all of these influencing factors that influence the plant's overall production, there's a lot of these on here that's very controllable. It's not anything just really out of the realm that's overly crazy to control. So if you look at just the very first one, at the exhaust temperature, that's something that the operator's controlling every single day, literally with a push of a button. Excess air, what does that mean, Lance? That means that is air required in the system to burn off anything excess that is not consumed in the combustion process. So if there's some kind of extra emission that you have to have, typically this is with the burner. The burner is having to introduce more air into the system past the combustion process. This could be as much as 200% on certain arrangements of equipment. And the baghouse has to be able to handle that, because you're adding more air into the system. So this is something that, again, kind of what I showed earlier with the stockpiles, is that we can engineer that out. If we know that up front, we can engineer that out. So it's very acceptable. Mixed temperature, well, that's a factor that we can control extremely easy, is that we know that every day. There's a little red button. Well, not necessarily red, don't hit the red button, but there's a little display there that is telling us what the mixed temperature is all the time. And we know that as you increase the mixed temperature, all you're doing is wasting fuel and oxidizing the mix. So that's 2 easy things, exhaust temperature and mixed temperature, that the operator can control instantly. Leakage air, that's all the air like in the the chutes, a baghouse with holes in it, baghouse with ductwork that's got holes in it. That's easily fixable. Get up there and get some steel and find it and patch it. Radiation loss, you're not going to get all of it, but things like insulation, like I've already went through on the tank farm, and even the drum shells. Some drum shells are not insulated. If you have a real long embedded burner style counterflow drum, insulate it. Make sure that it's got insulation on it, so that way you're trying to retain as much heat as you can. Now, things like in the environment is where it gets a little different, right? Is we can't control the elevation. We can't control where we're sitting at. However, I put an X there, but we can still engineer that into the system, right? Is if we know where the plant's going to be and where it's going to be sitting, we know the elevation and we know where it's going to be at. The moisture content we can control. That's something that we can do a really good job, maybe a better job or a good job, however you want to say it. We can control that, right? For grading our stockpiles, even in Europe, overseas. And again, I know I went there. I know I'm talking a bunch of guys from Michigan, but still overseas, they'll put materials in buildings. They'll even build like bunkers and keep material in bunkers to keep the moisture content down. But that's something that we can learn from, to use their practices and practice them here in the States. Ambient temperature, we can't help that, and material temperature. I put an X there, but still, you probably could somewhat handle that, because if you can control your moisture and where you're putting it, the temperature doesn't have that much of a swing. But still, in all reality, we can't control the weather outside. We can't control what's going on. We can't control Mother Nature. So I still put an X there, because we can't control if it's going to be cold or hot that day. So if you leave, if I'm going to wrap up here, and if there is nothing else that you left with today, I hope that again, going back is moisture is key. Is that if you want to save money and you want your plants to operate as efficient as they can, controlling your moisture is the most important thing that you can do, and will save big bucks. And if you do that, you can go to your owners and your uppers and your accountants and say, show me the money from what I've saved you, because controlling that moisture is key. It's the most important thing. So this is my contact information. I hope this information has been helpful to you. If you have any questions, jot my phone number down, jot my email down. I'd love to discuss it with you. If you want to shoot me an email, that's fine. If any of this is ringing a bell and you want to go down this further, I suggest getting with your vendor of choice. There are plenty of super smart, intelligent people out there, and they all will want to be glad to help you and want to help you. And of course, we at Aztec would love to help you too. But if there's anything we can do, please reach out, and I appreciate your time.
Thank you, Lance. That was very informative. I appreciated the summary back to the 3 points. That was very helpful for me to remember those things and take that away. So as a reminder, we sent out a thing during Lance's presentation. If you have questions, feel free to open up the Q&A box and type those in. We've got a couple, Lance, to ask you here as people are thinking about other ones. To the item number 1 about sloping the stockpile yard. Your drawing is still up there, and you talked about the 4 foot on the high side, 6 foot on the low side. I guess I'm guessing it's kind of leaning in towards a percent slope there, but obviously that'd be a function of how long that stockpile is too. So do you have any in percent what somebody should strive for if they're going to take the time and put the energy in to slope their stockpile yard? Are we talking 1%, 2%, 3%? Obviously, as percentage goes up, that's more material you're moving. So
that's right. I typically, everybody would just say, whatever you do here, do here. So if it's 6, do 6 here. So whatever that slope may work out to be, whatever that grade is, we in some technical manuals, we would do it at like 4 foot. 4 foot from this point over a 4 foot difference. So I don't know whatever that rise and run is. I don't know the ratio. Is that 1 to 4? Would that be 1 to 4?
Well, I think so. Okay, so it's a run of 1 or 4. I mean, obviously it's got to be 4. Otherwise, if it's a run of 1 and you're dropping 4 feet, that's quite a bit aggressive for a slope. Yeah. That's why I was saying it's obviously a function of how long that stockpile is. So that's why I didn't know if you had a percent.
Yeah,
something in percent.
It's in the example that I kind of pulled from. This overall diameter is about 75 feet.
Okay.
So even if it was just a square, a rectangle like the one that I showed on the screen, you know, it's kind of like a rectangle. It was about 75 feet from end to end.
Okay.
I hope that helps.
Yeah. All right. We've got another question here. Can you discuss the importance of utilizing sun direction to help dry the stockpiles? That's one thing I think, just to kind of to tack onto that. You know, Napa's working on updating some of their guidance on, you know, ways to become more efficient at their asphalt plants. And a lot of the folks down south talk about covered stockpiles. Well, that's, you know, that's great down there where they get, you know, rain every afternoon. And, you know, but up here in the north, we hope to use the sun to dry out aggregates, especially when it gets colder. Covered stockpiles will tend to freeze and or not dry out. So, but that's a good question. You know, talk about it, utilizing sun direction to help dry stockpiles.
Yeah.
So do you have any thoughts on that, the importance of utilizing sun direction?
I mean, I think it's gigantic. It's, you know, anytime you can use that to your advantage, you do it, right? I mean, that's why we try to put solar fields up on good flat areas where, you know, when it rises in the east and sets in the west, you have that optimum amount of time for the sun to hit it. Now, typically most asphalt plants are in fairly rural areas, and I understand that there are plenty that are not, and they're right in some metropolitan of Detroit or something like that, you know. But utilizing sunshine is absolutely critical if you can, and having the loader pull from that side. You know, if you've got a side that's got a lot of radiant heat that the sun is bearing down on, have the loader pull from that side. He might have to roll, you know, go around, but still utilizing that is a big deal. I would highly recommend it. And of course, that means the higher on the pile, the less moisture it would have. The higher you get, the less likely it would be to be soaked with water.
Sure. Okay. I know you kind of shied away from providing any numbers on, you know, payback or anything like that, but I thought I'd still put you on the spot on the VFW or the VFD exhaust fan. Any thoughts? I know it obviously varies on, you know, amount of production and everything like that, but like just on average from the folks that you've worked with to switch over, is it a year payback, a 2-year payback, or what do people typically see? Again, you know, knowing that everybody's different and well, I was just curious.
No, I appreciate the caveat, because again, I don't, my whole purpose is I don't want to mislead somebody. I want to set expectations and make sure that I'm meeting those. So with that caveat that you said, you know, historically on average, I'm just going to use round numbers, okay, because it's a lot easier, is that adding a VFD might be somewhere between $30,000 and $40,000, depending on where it is, what it needs, if it needs controls, if it needs, you know, outdoor rated cabinets. You know, you can do it a bazillion different ways. So your typical investment from a vendor to get it is somewhere between $30,000 and $40,000, you know, something like that. So we have had customers pay that back in as quick as 6 months. And so that would mean if you spent $30,000 to put it in, you paid that back in 6 months. Well, that means annually that's 60 grand a year that you're saving, because if you did it in 6 months, if you spent $30,000 and spent that in 6 months, then that's $60,000, you know, of savings that you'll get from that year forward.
Okay. Yeah. I mean, assuming that you're in an area of the country where you can pay 12 months, but yeah, that's
great.
Our payment.
Nobody's in that. Yeah. Nobody's
6 to 9 months. So, but that's helpful. So it's significant enough that, you know, if you run the numbers, it's probably worth setting down with a scratch pad of paper and running the numbers, because it might be a year or two. So
it is. And I don't have, again, I don't have problems giving budget, you know, like, again, budgetary numbers, is that typically sloping and grading stockpile areas, we have seen customers pay this back in as quick as 6 months on fuel usage in the plant because it's not running as much. So that could be, I've seen some numbers as much as, 100, 120 grand, depending on productivity, how much moisture they have. If it's in Arizona where it has no moisture compared to Southern Florida where it's soaked all the time, the variables are a lot different. So the problem with this is that you have to use asphalt, right? I mean, you have to use your product that you would rather sell to a contractor or to a laydown guy. You're using that in the yard. So you have to find the ROI to get that back. And you do that through the fuel usage that you wouldn't use. And we've seen customers pay this back quickly. We've seen them pay it back over the course of a year. But I would say somewhere around, 100 to 120 grand a year, something like that of fuel savings of just paying for that.
I was my assumption when you were going through your presentation and you had the 3 items that you kind of presented those in the order from kind of greatest to least, but I thought I'd give you the opportunity just to either confirm that or right. So that was my assumption, but I think, the tank farm thing did seem pretty eye-opening. I don't know what it costs to insulate pipes, but I would imagine, it's something that it's not very scientific, right? You can.
No, I have seen it as, I've seen it as cheap as, they do it themselves. They buy their insulation and their paving crew during the wintertime does it. They pull everybody in and they all jump on it and do it. And they spend $15,000, $20,000. I've seen contractors have to pay, $60,000 and $70,000 because they want it just top of the line, and they want all this extra stuff on it. And they want everything. And again, when the plants get large and you get these big tank farm areas, of course, that's just more surface area, right, that you have to wrap. So it gets more expensive. So you could typically, I'd just say somewhere around $40,000, to wrap a plant. And they typically pay that back. That's a longer payback, but still it'll pay itself back over the course of about a year. So, and every year past that, you're going to be saving somewhere around $30,000 to $40,000. And the issue with this scenario is that a lot of people are burning natural gas, right? And natural gas is extremely cheap. If everybody was burning diesel and diesel was $4 a gallon, there would be no insulation in the stores because everybody would be wrapping their equipment because they're trying to save the best they can to drive their mix costs down. So it's kind of one of those things that a lot of people don't. That's another reason people don't do it, is because they say fuel's cheap, natural gas is cheap, I'm not spending that money. It takes too long to pay it back. My return on investment is too long. So that's that. I hope that helps.
Yeah, no, very, very much so. So, well, I think we're wrapping up here in the questions in the Q&A box. So I'm gonna. I just wanted to kind of wrap things up here and again thank our sponsors for today's webinar and the asphalt plant webinar series. So again, Aztec, CWMF, and Meeker for their generosity here in sponsoring this series. I also want to thank Lance for his time putting together this presentation and spending over an hour here with us, imparting some knowledge on us. And again, thank you to the audience. If you missed anything today, we did record this session, so we'll have it out on our YouTube channel. So feel free to contact us if you don't end up getting the link. We'll follow up probably in the next day or so to an email to all the attendees with Lance's contact information and a link out to YouTube so you can watch this recording and or share it with others in your organization. And then also stay tuned for more webinar series. We've got one more coming up in the asphalt plant space. And of course, as always, if there's any webinar topics that the audience would like us to work on, feel free to shoot myself or Chuck or Beth an email at the association on what it is you're hoping to hear about. And we would be more than willing to visit that and see what we can get together on that topic. So with that, I guess I'll end things for today. And again, thank you, Lance. Thank you, everybody, for participating, and thanks again for sponsors, and hopefully everyone walks away with some ideas on how they can show themselves the money. So thanks again. Have a wonderful day. Stay safe out there, and we'll see you all soon.